Hey everyone, hope you're doing well today. In this video, let's practice writing 6 trig ratios given a point on the coordinate plane. Alright, in this first example, we have this point P, and it's located at 9, -12, and it's on the terminal side of theta in standard form. Find the exact values, which means we're going to be using radicals and ratios, and we're going to not use a calculator, of the trig functions of theta. Now, if I were you, I would just start by drawing a little coordinate plane, the little x and y axis here, and then so we can go ahead and plot this point. So for this first coordinate of 9, that's going to be 9 units to the right since it's positive. So I'm going to go ahead to the right and just write a +9. And then for the second coordinate of -12, that's the y coordinate, so that's going to be moving down 12 units. I'm going to put a -12 next to that one. Okay. Once you have that, what you're going to do is you're just going to go ahead and connect this last part. This is going to be the hypotenuse of this triangle, or the radius, whatever you want to call it. I like calling it r for the radius, and then this is going to be where your theta is. Now remember, you have this Pythagorean theorem of a squared plus b squared equals c squared, but in terms of trig, we typically use this x squared plus y squared is equal to r squared instead. Substituting in, we can go ahead and say that we have this +9 squared plus this -12 squared, and that's going to equal r squared, right? And then this is going to be 81 plus 144, and that's going to equal r squared. 81 plus 144 is going to be 225 is equal to r squared. And if you take the square root of both sides, you're going to find out that r is going to equal 15, right? And so r is always going to be positive. That's going to be the radius of the circle if you were to look at this as a circle going around, and the r is the hypotenuse. Now, a lot of people use this acronym for Sohcahtoa for the ratios for each of the main 3 trig functions. But keep in mind that we can also think about it like this, that the sine is always going to be the y over the r value, the cosine is always going to be the x over the r value, and that tangent is always going to be y over x. So you can think of Sohcahtoa as the same thing as seer, cosere, tix, if that works for you. But this is going to be super useful when you're dealing with the coordinate plane. So for the sine ratio, we know that's going to be y over r, or -12 over whatever we found out r was, which was going to be 15. So we can go ahead and write that as sine of theta is the ratio of -12 over 15, and then divide both by 3, or the GCF, and we're going to get 4/5. So -4/5 would be the ratio for sine. Now for cosecant, that's just going to be the reciprocal, so I'm just going to go ahead and flip that upside down right away. For cosine, let's see what cosine is. It's going to be x over r, so the x coordinate here is going to be 9, and the r coordinate, or the hypotenuse here, is going to be this 15 we already figured out. So we're looking at 9 over 15. So for cosine, we're going to say it's going to be 9 over 15. Divide them both by 3, or the GCF, you're going to get 3/5. And secant is the reciprocal of that, so we're going to write 5/3. Finally, for tangent, which is going to be y over x, well, y is going to be the vertical value, up and down, that's -12. X is going to be the horizontal, so it's going to be 9, so -12 over 9. So tangent's going to be -12 over 9. Divide them both by 3. And we're going to get -4/3. That's tangent. And then for cotangent, that's the reciprocal of -3/4, right? If you remember your acronym for ASTC, this hopefully makes sense why each of these are positive and negative in these particular quadrants. Cosine should be the only one that's positive in quadrant 4. So that's why cosine and secant are positive. But for all the other trig ratios here, we're really going to have negative values, right? So sine and cosecant always will have the same sign, and then tangent and cotangent are all negative just because they are in quadrant 4, and only cosine's positive there. All right, let's try another one here. For number 2, we have the point Q, which is going to be at -5, 12. Let's go ahead and plot that on a coordinate plane first. So our first coordinate here is going to be -5, so we're going to go 5 to the left. Okay, and then that's going to be -5, and then we have a +12 as our y coordinate, so that's going to be going up 12 units. So I'll go something like this, that's +12, and then we have our radius, which is going to be going over here, and I'm going to call that r for now. Okay, just like we did earlier, we're going to start off with our Pythagorean theorem, but I'm going to use x squared plus y squared is equal to r squared. X squared is going to be -5 squared plus y squared, which is going to be 12 squared. That's going to equal r squared. And then 5 squared is 25. 12 squared is 144. And that's going to equal r squared. Adding those together, we're going to get 169 is equal to r squared. And if we take the square root of both sides here, we're going to get r is equal to 13. All right, so we now know the value of r. And if we go ahead and think about our ratios here, if we have sine, remember, is going to be y divided by r. Cosine is the ratio of x to r. and then tangent is the ratio of y to x. So if we go ahead and try substituting these in, for sine, it's going to be y over r, so the y coordinate here up and down is 12 over the r coordinate, which is 13. We know that's going to be, the ratio is 12 to 13 here, okay, which means that cosecant is going to be 13 to 12 for that ratio, okay. Let's go on to cosine. Cosine is going to be the x coordinate over the r coordinate, so x is negative 5 over r, which is 13, so negative 5 over 13. So we can go ahead and write negative 5 over 13, and that means secant is just going to be negative 13 over 5. Finally, for tangent, let's try that one. Tangent is the ratio of y over x. So y is going to be positive 12, and then x is going to be negative 5, right? So we don't need r for this one. And so it's going to be this negative 12 over 5. And then for cotangent, it's going to be negative 5 over 12. Now to check the signs, just to double check, we have A, S, T, C. Remember, only sine is positive in this quadrant, so sine, we do have a positive, and its reciprocal of cosecant is positive, and then all the rest of them should be negative here, because in quadrant 2, only sine is positive. Let's try a third one here. For number 3, let's see the point we're dealing with here. This is going to be 3 comma negative 4, and so the first thing we're going to do is let's put this on the coordinate plane. So x coordinate is 3 and y coordinate is negative 4. So we'll go 3 units to the right here. That's positive 3 for the x coordinate. And we'll go 4 units down because we have negative 4 for the y coordinate. And then again, we don't know the hypotenuse, or we don't know the radius of this circle. That's going to be r. Okay. We'll go ahead and use our formula here. If you recognize these Pythagorean triples, that's awesome. That will save you a little bit of time. But we have x squared plus y squared is equal to r squared. We can say that's going to be 3 squared plus negative 4 squared is equal to r squared. That's going to be 9 plus 16 is equal to r squared. That's 25 is equal to r squared, and take the square root. So r, or the radius of this, is going to be 5. Okay. Try to remember our ratio of this. Sine is y over r. Cosine is x over r, and then tangent is y over x. If you practice writing enough, it'll stick in your head. And let's go ahead and see if we can write the ratios here. So for sine, let's go ahead and do that. That's going to be y over r. So this is our y coordinate of negative 4 over r, which is going to be positive 5. So it looks like we're going to have negative 4 over 5. Negative 4 over 5, which means that cosecant is going to be negative 5 over 4, the reciprocal. Then we go over to this cosine. Well, cosine, what do we have there is x over r. So here's x, that's positive 3 over r, which we found out is 5. And so that's positive 3 over positive 5. Positive 3, positive 5. Secant is the reciprocal, so it's 5 over 3. And then finally for tangent here, it's y over x. So y is this negative 4. X is this positive 3, so negative 4/3. And then cotangent is going to be negative 3/4. And then finally for tangent here, we have y over x. So here's y, and then here's x. So that's going to be negative 4 over 3. We'll write negative 4 over 3. And for cotangent, that's going to be negative 3 over 4. Okay. We're in quadrant 4 here, so A, S, T, C. Only cosine's positive here, so just double check. Cosine is positive, and secant, we did get a positive value. And make sure everything else is negative in quadrant 4. So this is negative, 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 and negative. And so that all checks out. So that makes me feel a little more confident that we got the correct signed values at least. All right, let's check out a fourth one here. In this case, we have a point K. And so point K is located here. Let's go ahead and throw that on a coordinate plane. All right, so here's our coordinate plane. And we're going to go 8 to the left and 6 up. So if you want to try this on your own, go ahead. But we're going to go 8 to the left here, and then we're going to go 6 units up, something like this, positive 6. And then for our hypotenuse, or the radius here, that's going to be here. That's going to be r. If you want to write theta, this might be helpful just so you're aware, but hopefully you know that's there. And let's see. We know we have our equation for Pythagorean Theorem of x squared plus y squared is equal to r squared. For x, it's going 8 left and right. And for y, it's going 6 up. So we're going to square that, and that's equal to r squared. Negative 8 squared is 64. This is 36. This is r squared. This adds up to 100. Kind of nice. So this is actually another Pythagorean triple. R is equal to 10 here. Okay, so we now know that. And so what are the ratios? If you're starting to get the hang of it, good. We have seer, and then we have seer, and we have tix. Okay, and as we do sine, it's going to be y over r, so y is up and down. That's positive 6 over r, which is this positive 10, so positive 6 over positive 10. Right, 6 over 10 divided by their GCF of 2, that's going to be 3/5, which means that for cosecant, it's going to be 5/3. Okay, let's go ahead and try cosine. Cosine is going to be x over r, so here's x, it's negative 8 over r, which is 10. So we have negative 8 over 10. Divide both by 2, so that's negative 4/5. But that means that secant is going to be negative 5/4. Finally, for tangent, we have y over x. So here's y. That's going to be 6 over x, which is negative 8. So positive 6 over negative 8. So negative 6/8. Divide both by 2. That's negative 3/4, which means this is negative 4/3. Just to check the signs of everything, this is ASTC. Only sine should be positive in this quadrant, so we do have a positive ratio and a positive ratio for these two. And it looks like we do have a negative ratio, negative, and negative. So in terms of messing up signs, we should be good to go. Let's check out a fifth example here. These aren't necessarily going to be Pythagorean triples, so we might get some radicals we have to deal with here. So for point P, we have 3 comma negative 9. Throwing this on a coordinate plane, we have 3 to the right and 9 down. So let's go 3 units to the right here. That's going to be positive 3. And let's go 9 units down. So all the way down here. And then let's go ahead and just draw the hypotenuse or the radius. Okay, and so that's going to be r. And we need to figure out what that is, just like we've done in the last few. So we know x squared plus y squared does equal r squared. X squared is going to be positive 3. We'll square that plus this negative 9, and we'll square that, and that's going to equal r squared. 3 squared is 9. 9 squared is going to be 81. That's equal to r squared. Now 9 plus 81 is 90, so we have 90 is equal to r squared. Then we have to go ahead and take the square root of both sides here. Now, to figure out the square root of 90, try to keep in mind that 90, if you break it into some prime factors, we have 10 and 9. Then we have 3 and 3, and we have 5 and 2, a little throwback from pre-algebra. And so when you have two matching primes like 3 and 3, that makes a perfect square, so that's 9. So, and these ones aren't a perfect square because they don't have any pairs. So 9 times 10, so we can break this up into root 9 times root 10, and the square root of 9 happens to be 3. So we can say the radius is 3 root 10. All right, so that's going to be r for this problem. Remember, r is always positive. X and y can be negative or positive, but the radius is always positive. Now, what's our ratio? Sine is y over r, cosine is x over r, and tangent is y over x. Okay, and so sine, let's go with that one. That's y over r. Y is this, right? And then r is going to be this 3 root 10. So y over r, that's going to be negative 9 over this 3 root 10. You can divide both by 3 on top and bottom, their GCF, and you're going to get negative 3 over root 10. And keep in mind, we need to rationalize the denominator, so we're just going to multiply by root 10 over root 10, and that's going to be negative 3 root 10 over 10. Okay. Now for cosecant, cosecant is the one right over here. Remember, sine and cosecant are reciprocals. So just go ahead and take this simplified version and flip it upside down. So we can say it's negative root 10 over 3. Like, don't worry about starting from the beginning. Just take the simplified version, flip it upside down. And if you had to do this whole mess of like rationalizing the denominator for one of them, you don't have to do it for the other. So just keep that in mind, that you just use that information to help you with another one. All right, moving up to cosine. For cosine, we have x over r. So here's x, it's left and right. And then r is the hypotenuse. So it's going to be positive 3 over this 3 root 10. So positive 3 over 3 root 10. And you can cancel out the 3's, their GCF, and you get 1 over root 10. So before I even keep going, I'm just going to make this root 10 over 1, which is just root 10 for secant. And then so I will rationalize this one, but I didn't have to rationalize the other, which is kind of nice. So it's going to be root 10 over 10. Finally, for this last ratio for tangent, it's going to be this y over x. So tangent is going to be y, which is -9, over x, which is +3. And so y over x, that's -9 over +3, which is just -3 over 1, or just -3. And then if we simplify that, what is that going to be? Well, if we had -3 over 9 for cotangent, that's going to be -1/3, which is the reciprocal of -3. Right? We are in quadrant 4, so everything's positive here. Only sine, only tangent, only cosine. So only cosine should be positive. Is that true? Well, yes, we did get a positive and a positive ratio. And then did we get negative ratios for everything else? It looks like it. So our signs are all correct because we set up our x and y values with the correct signs. Let's try number 6. Number 6, we have this point -4, -7. Let's go ahead and put it on a coordinate plane. So we have 4 to the left and 7 down. So let's go 4 to the left here. It's -4. And then 7 down. So we'll go -7. And let's go ahead and connect these to make that triangle. That's going to be r. And this is going to be our angle measure. All right, so let's figure out r. We have x squared plus y squared is equal to r squared. X is -4, so -4 squared plus -7 squared is equal to r squared. This is going to be 16 plus 49 is equal to r squared. 16 plus 49, I think, is 65, is equal to r squared. If you take a square root of both sides, we get r is equal to the square root of 65. Now, you should check to see if there's like any perfect squares hidden inside. I don't think there are. I think this is 5 times 13. I think they're both prime numbers, so there's no way to simplify this radical, so just leave it alone. We have our ratio of sine is y to r. We have cosine is x to r. And we have tangent, which is y to x. So we'll start with this sine ratio, which is going to be y over r. So that's going to be y, which is -7, over r, which we found out is the square root of 65. So we'll write -7 over the square root of 65. And we got to rationalize this. Before we do that, I'll go ahead and write the cosecant one. So it's going to be -√65 over 7. All right. But if for the regular sine one, let's rationalize it by multiplying by √65 over itself. And if we do that, we're going to get -7√65 over 65. Okay, so just keep that in mind that we can go ahead and do those together just because they're paired up. Now for cosine, we have x over r, so x is going to be -4, and then r over here is going to be this √65. So we're going to have -4 over this √65. Which means that for secant, that's just going to be -√65 over 4. One of them we have to rationalize, so for this, just like sine, we're going to do the same thing here. And if we multiply that, it looks like we're going to get -4√65 all over 65. All right, we'll leave it at that. Finally, for tangent, tangent's going to be y over x. So here's y, and then here's x. So it's -7 over -4. Negative over negative is just a positive, so I'm going to write 7 over 4. And then for cotangent, I'm going to write 4 over 7. So checking our signs, we have the tangents, which are positive because negative over negative was a positive. And then everything else here seems to be negative, so that all checks out. Moving on to 7. If you're getting the hang of this, by the way, feel free to pause the video and try a couple on your own. Otherwise, I'll just keep on going through these. Okay, so let's go ahead and put this on a coordinate plane. And so this +5 and -2 means we're going to move 5 units to the right. That's going to be +5. And that -2 means we'll move 2 units down. So that's going to be -2. And we can go ahead and connect this to make a lovely triangle. Here's our theta. I feel like sometimes I forget to write it right over here too. Doesn't really matter, but hopefully you know where that is. And we need to figure out what this r value is. And so I'll go ahead and do that now. Plug in 5 here, 5 squared plus -2 squared equals r squared. R squared equals 29, so the square root, 29 is a prime number, so we don't have to worry about that at all. That's just going to be √29. Here are our ratios once again. Hopefully that's starting to stick with some practice.
Sine is going to be y over r, so here's y, it's negative 2, over r, which is going to be root 29, so it's going to be negative 2 over root 29, which means that if that's sine, then for cosecant, we're going to get root 29 over 2, and that's going to be negative still, right? For sine, we will rationalize this, multiply by root 29 over root 29. If you go ahead and do that, we're going to get negative 2 root 29 over a normal 29 now, okay? If that's the case, we can move on to cosine. Cosine is x to r, so x is over here, r is over here, so it's positive 5 over root 29. So positive 5 over root 29, which means for secant, it's going to be root 29 over 5, okay? We can go ahead and rationalize the cosine ratio, multiply by root 29 over root 29. And if we do that, we will have 5 root 29. I'll go ahead and see 5 root 29 over a normal 29. Okay, it's very similar to the sine one here. Okay, and then finally here we have tangent, which is going to be the y value of negative 2 over the x value of positive 5. And so we will go ahead and write negative 2 over positive 5. And then for cotangent, we can just write negative 5 over positive 2. Over in quadrant 4, we should only have cosine be positive. Let's see if that's true. This one is positive, and its reciprocal of secant is also positive. And it looks like sine is negative, cosecant is negative, tangent is negative, and cotangent is negative. So all the signs make sense. Here is one final one we have for number 8, point K, which is located in negative in this quadrant of 2, which is negative 6 comma positive 4. Let's go ahead and throw it on a coordinate plane. So we'll move 6 units to the left and then 4 units up. So we'll go 6 units over to the left. That's going to be negative 6. And we'll go up 4 units, something like this, all right, plus 4. And then for our radius or the hypotenuse, that's going to be r. And here's our theta. And so just like the last few examples, let's figure out r. All right, so using the Pythagorean theorem here, we found out that r is equal to the square root of 52. And just going ahead and seeing if we can simplify that radical at all. 52 is even, so it's going to be 2 and 26. And then 2's prime. 26 is 2 and 13, so 13's prime, 2's prime. So we have these matching 2's, which means that we can simplify this to, or we can break it up into 4 times 13, because 4 is a perfect square. And then we can simplify that more and say the square root of 4 is 2. So we have 2 root 13 for the radius here, okay? Here are our ratios for sine, cosine, and tangents. So for our sine ratio, that's going to be y over r. So it's going to be positive 4 over this 2 root 13, okay? So we'll go ahead and write that as positive 4 over 2 root 13. You can divide both top and bottom by 2, so it's going to be 2 over root 13. Before I keep going, I'm just going to flip that upside down for the cosecant function and write root 13 over 2. And then I'll go to the next step and rationalize this by multiplying by root 13 over root 13. So this is going to be 2 root 13 over 13. Okay, and then let's move on to the cosine ratio. It's x over r, so here's x. It's negative 6 over r, which is this 2 root 13. So we have negative 6 over this 2 root 13, 2 root 13. We can divide both top and bottom by 2, so it's going to be negative 3 over root 13. Uh-oh, running out of space here. For secant, I'll just flip that upside down. It'll be negative root 13 over 3. And to rationalize this, let me just go ahead and bring this down to the bottom here. So let me go ahead and move this. So for cosine, if I go ahead and continue that, we were at what? Negative 3 over root 13. I'm hopefully getting the hang of this, but if I write this out as times root 13 over root 13, then we will end up with negative 3 root 13 over 13. Okay, I'll go ahead and just erase this to get some more space here. We can go ahead and write that as our final answer. That'll be negative 3 root 13 over 13. And then finally, for this tangent ratio, we have y over x. So y is going to be positive 4, and then x is going to be negative 6. So we're just going ahead and write negative 4 over 6 and divide both by 2. That's going to be negative 2 over 3. And then for a cotangent, it's going to be negative 3 over 2. Let's see. We're not in quadrant 1. We are in quadrant 2. So only sine should be positive. Looks like sine does have a positive ratio, and its reciprocal has a positive ratio. Looks like cosine's negative, tangent was negative, secant's negative, and cotangent's negative. So there you have 8 different examples of given a coordinate on a coordinate plane, and going ahead and using what you know about trigonometry to figure out the 6 different ratios for sine, cosine, and tangent, and the reciprocals of cosecant, secant, and cotangent. So hopefully you found this video helpful. There is a PDF in the description in case you'd like to download that PDF and try it on your own. But as always, keep up the great work, and I will see you in the next one.